So we're going to add and subtract polynomials, and in this particular case you're looking at numbers here on the first little bit of this video, and you might be wondering why. Because the rules, the processes that we use with numbers, if they work, they should work with polynomials, and if they don't work, then they should not work with polynomials. So we're not going to do anything special with polynomials. If our operations and our procedures don't work for normal numbers, if it gets us some false statements, then we know we can't use those for polynomials. So let's take a look at this problem. If we were to do this maybe the intuitive, traditional way, you would say, okay, this is 5 minus, and then figure out what's in these parentheses, right? So 12 here, minus 2, so 10. So 5 minus 10, so this whole thing should equal -5, right? Well, if we, rather than solving each set of parentheses, if we were to get rid of the parentheses and just work it left to right, would we still get -5? That's the question. Because that's kind of the procedure that we're going to use to add and subtract polynomials. So we can imagine, if you will, a positive 1 right here outside this set of parentheses and a -1 outside this set of parentheses. And the reason that is because 1 times anything is itself. So 1 times 7 minus 2 is just 7 minus 2. But this over here is interesting because it's a negative sign. And so this is actually a -1 times all this inside here, which is actually going to change the sign of all these things inside, of all these terms, the 4, the 8, and the -2. And we need to get rid of these parentheses, we need to essentially distribute whatever's outside the parentheses. So like in a separate problem here, so we'll move on from this, we'll come back to it. So if I had 3 times 5 minus 2, of course I could distribute to get 15 minus 6, which would be, as you know, 9. And if I had just done the 3 times the 3 here, if I just made this 3 times 3 also equals 9. So the point is, distribution gets rid of parentheses, because I had just written, okay, 3 times 5 is 15, 3 times -2 is -6, so right here, no parentheses, and I can move on. So we'll do the same thing up top here. Oop, let me get rid of this real quick down here. So let's distribute. So we get 7 minus 2. Now I'm going to have -4, -8, and +2. Because -1 times 4 is -4, -1 times +8 is -8, and -1 times -2 is +2. Now let's work it left to right. So here I get 5 minus 4, I'm going to get 1 minus 8, I'm going to get -7, and -7 plus 2, I'm going to get -5. So I worked it out left to right, and I got the same thing that I would have got if I had just done it the traditional way. So this allows us then to get rid of parentheses through distribution and work it left to right. Let's now apply that to polynomials. So now let's apply what we just learned about distributing the 1 and the -1 to get rid of parentheses, and let's solve this polynomial subtraction problem. So there's a +1 here and a -1 here. We distribute and we get 3a squared plus 1, and then we get -4 and -2a squared because of the -1 being distributed. And now we just have to look for like terms. I've got a like term set here, and these two in the middle are like terms. So we've got a squared, it looks like, and -3. Because 3a squared minus 2a squared. So we have to take note of the sign of the coefficient. It's a -2, make a single a squared, and then +1, -4, get us at -3. Now this one looks a bit more challenging, but it's really exactly the same thing. We're not going to do anything special for it. I am going to try and write small. So the first thing I'm going to do is rewrite this whole thing, getting rid of parentheses. So I've got this term here, 4x squared. That's going to stay. I'm not doing anything to that yet. And the 7x cubed y squared. But now I'm going to distribute this -1 to all the terms. Let me switch colors here. To all the terms inside. Oop, and that one all the way over there. So that's going to change the sign. So this is going to become a positive 6x squared. And that's all I'm doing right now is I'm changing the signs of the terms. 7x cubed y squared and positive 4x. And I'm only changing the sign of the terms because of the -1 out front. If it was a positive, if this was like a plus sign over here, if this was a plus sign, all the signs would stay the same because they'd be distributing positive 1. But again, I have a negative 1 here, so it's going to be negative 10x, negative 9x squared. Now, for the part where mistakes are often made, the distribution of the ones, I think, are pretty straightforward. You just got to remember to do it. But here things get messy, right? We're looking for like terms. And so everyone needs to kind of come up with their own procedure so that they make less mistakes. And so I like to just start with the first term on the left. And I basically ignore the coefficient for a little bit, and I just go, okay, x squared. I'm going to go and find everything that's x squared and like do something, mark it or something, so I can keep track of it. So I've got my x squared here. Looks like I've got an x squared here and an x squared here. Then I just actually solve them. I take note of the coefficients now, and I add them left to right, skipping all the stuff in the middle that's not a like term. So this is a positive 4, this is a positive 6, so I'm at 10x squareds, and now I've got to take away 9, and 10 take away 9 is 1, so I know I'm going to have just 1 x squared in my final answer. And then I like to cross out what I've taken care of to help me keep track of what's still there, and it's kind of an efficient way to go about it. It's just my method. You create your own, if you will. And so now here I have an x cubed y squared. Got one here as well. So looks like those are the only two. So I'm going to combine those together. 7 and 7, since they're both positive, make 14. Positive 14 x cubed y squared. So I can cross those out. Oops. Let me use that same blue there. And I notice that I've got just a normal number here now. So I've just got a 7. Oh, no. That's been crossed out. See? It's really easy to make mistakes. The 7 is the coefficient of x cubed y squared. I already took care of that. So now I notice, oh, I've just got these x terms. They're the last things left in this problem. So I'm going to just combine those. And positive 4 and negative 10 make negative 6x. Cross those ones out. And I think I've taken care of everything in the problem now. And so it'd be a good idea to go back and check to make sure you did it right. Just kind of go through the process again and double check yourself. But other than that, that's really all there is to it. It's a matter of staying accurate and kind of coming up with your own system so that you don't make multiple errors. And that's really the goal, is to be accurate with these.